right. Good morning, everyone. Happy to be here today, presenting at the application stage of Formnext 2024. Together with my partner Tobias, we have the big pleasure to introduce you to our presentation, presenting you what we did together to create the bicycles you can see right here, and the technology that goes along with that. Our presentation is called Strongest Bond, how metal AM and gluing help industrialize additive manufacturing in the bicycle industry. To start off, we would introduce each other's first, so you know who's at the stage. Tobias, please start. Tell us something about yourself and about Möve bikes.
Yeah, thank you. First of all, I wanted to introduce myself. I'm sorry for my English. I'm a little bit rusty because I don't spoken in the last years. It's only school English, and if I don't find the right words I want to describe and so on, yeah, okay. Yeah, my name is Tobias. I'm CEO of Möve Mobility. We are a little manufacturing company of e-bikes. I'm 44 years old. I have 3 children, and yes, we want you to introduce our project and the impact of this whole project, because it's more than an e-bike.
Definitely it is. About myself, this is actually an old picture of our booth from last year at Formnext. We are here this year at Hall 12.0 E101 if you want to visit us later. Our company is Eplus3D. We are a manufacturer of powder bed fusion metal printers. Amongst them is also the largest powder bed fusion metal printer in the world with 2x2 meters X and Y. About myself, I'm 31 years old now, taking care of our whole business in Europe, where we have installed 100 metal printers since 2017 already. And yeah, happy to be here today. I would like to start off with just a little time schedule of what we have done in the past and how we have created this bike. Basically, everything has started last summer when, sorry to say that to Tobias, but slightly frustrated, Tobias has called me. I remember I was on the airport on the way to a business trip in the early morning, and we had a call, and he told me, I have this amazing project, but I cannot realize it because these parts are too expensive to produce. I want to make a bike that should be affordable. I want to compete to carbon bikes.
And sorry, Ines, at this moment I worked 3 years on this project, and I make my calculations, but yeah. Please go far.
So yeah, everything was too expensive. So I said, Tobias, send me over the parts. We're gonna have a look at it. We make some basic calculations first. So what we do in Additive, we checked the parts, we oriented them, we supported them, and we simulated it. And this is how our software interface looks like. And it seemed quite promising, so we continued together and we did a deep analysis. And until January of this year, we had a look at all of these parts that connect the tubes, and we analyzed them for productivity, for how to produce them. Then in January, I get another call because basically we have settled everything about these lugs that connect the bike. And I get another call. That time I was at Euromold, and Tobias called me. Well, Enes, we have a problem because we need these tubes, but later in serial production we want to make them from hydroforming, 0.5 millimeter wall thickness. But in order to get the first prototype, we need to make a tool. but maybe the shape will change later. So I heard you have such big metal printers, he said, and can you print these tubes? And I was like, yeah, of course we can. So he sent me over the geometry of these tubes. And the tubes you can see here, they are printed with our metal printers. We use some very special support structure. All of that is titanium, grade 23. We use some very special support structures to keep them straight, because usually they would deform if you would just print them straight. They would strongly deform, latest at heat treatment. But what did we do? We printed them on our M650. It's a 650 millimeter platform. This is just a short video where you can see we printed quite a lot of support structure, but this was necessary to keep the part straight. We printed 70 tubes in total, I think 70 or 80, in order to be able to make around 10 prototypes of this bike. Yeah, 70 tubes. This is how we delivered them. Just a few days later, I mean, we had the lugs already. Tobias sent me this picture from his office where he sort of connected the tubes already. And the first prototype was in reach. And we had quite an ambitious goal. You can see here we printed between January and March 2024. And then in March, there was a huge event that was our deadline, and the deadline for the first prototype, which was the Eurobike. Eurobike happened in this exhibition in Frankfurt. And yeah, Tobias filed for the Eurobike Award, and actually we were selected as a winner of the Eurobike Award for one of the most advanced concepts in the bike industry, which we are very proud of. And then everything took its way until September this year. We got a lot of traction on social media, and in the end, Tobias' company and this bike, the Avian, got awarded also the German Design Award 2025. As you can see, the bike is an e-bike, has an amazing design. So yeah, we got that prize as well. And Tobias introduced the Vertec technology, which is basically the connection technology between these. He will tell you something more about that. And now we are in November 2024 here at Formnext with the bike. And yeah, Tobias will tell you now what about the Vertec technology.
Klick durch. Okay, we have to hurry up because only 11 minutes. Okay, make it short. The idea is to make printing parts as small as possible because of the cost. You always have to have your costs in the view. This was the first goal. The second was how I produce in serious production the tubes. And I'm decided for hydroforming because of the cost. It's always the cost. And so I make these parts like a Lego principle. I created them to plug them together, and then comes the next step. I invented with my partner Zika Power Solutions from Switzerland. I created a new injection bonding, additive bonding process. First of all, we put all the things together. Then we inject here from outside in less or lower than 10 seconds for one chamber the glue. I have well-defined glue chambers. That's the most thing we have to concentrate on because we need a stiff frame set. Next slide. Now the finish, the surface. I'm going through the fair and I see at every booth higher, bigger. That's not the right way to go. Make it printing fast and think about the post-processing because of the costs. And I have a new partner. I make the acquisitions at my own, and we have a patented technology to make the surface of our parts not on this. This is a prototype A series, C series. On the A series, we have the surface of the MacBook. And we printed the parts as fast as possible because of the costs. Quality check in Germany. I'm a German engineer over 20 years. You know, make it safety first. I've done that. This bike, also this, we first of all checked, and we are stable, more stable than all carbon fiber frame in the world. Frame repair, sustainability, big thing. I have invented a technology to repair the frame after we glue. It's only 5 minutes, and we can change the parts. And also, at the end of the product life cycle, I can make the recycling for the lugs and for the tubes, because titanium is a very, very material.
It's expensive.
Expensive material. Yeah. Okay. Go on. What we've reached with my team, with my technologies and my IPs, I came down, if I compare it to a normal carbon fiber frame, from 36 hours production, you have to invest at the moment in Asia for one carbon fiber frame. I came down with 97% down. I'm under 1 hour to assemble this frame. The same, if I compare it to a normal aluminum welded frame, I go down 93%. I came back, make it cost efficient.
All right, and I think what this slide also shows, you know that Tobias mentioned carbon frames they're non-recyclable, they're made in Asia. With this technology, we can basically
nearshoring. We came back to Europe. We produced these frames in Europe at more of 40% lower than a carbon fiber frame from Asia now.
So thanks, Tobias, for elaborating the technology and Vertec more. I would like to give a little outlook of what we're going to do in the next upcoming months. Sorry for that. I made this slide this morning, I think, after waking up at 6:30. So the time schedule I just see now is a little bit messed up. But anyways, right now, as Tobias mentioned, this is still the prototype series. We are now in December finishing the design validation of the P3 prototype 3 series, making all the tests Tobias mentioned, and in earlier next year ramp up the production and deliver the bikes that you can already order on Tobias' homepage. Later in next year, sorry again for the years here, there will be further development of other bicycles, because with parametric design of these lugs, it's of course very easy with additive manufacturing.
And we go a same piece strategy. Yes, we use like a Lego principle to take more parts are the same, and want to changes only about the printing parts. Sorry. Ines.
Exactly. No, that's correct. So there will be more bicycle frames. This is now the gravel version. There's the avian itself. There's different sizes and possibly also customized size of bicycles. And then, of course, in the end, 2025, 2026, we will see licensing with Tobias' owned Vertec technology to the cycling and also to other industries.
Yes, I give you a short overview of my IPs. The IPs are technology open. And this kind of creation and IPs we can use also at automotive industry, machinery industry, architecture, powertrain, aerospace, if you want. The thing is, make it cost efficient.
It's about, for us, we're the machine manufacturer. Tobias is challenging us a lot. The main goal is productivity, productivity, productivity. And with that, I would like to end the slide. Here you can see a little picture of what this bike is assembled from. And yeah.
I have to say one thing last.
Go ahead, Tobias. We still have 3 minutes left.
Okay, the last thing I want to give you today is, if you had a hammer, not every problem looks like a nail. What I want to say is, make the parts for additive manufacturing as cost efficient as you can. And think about your processes to combine it with normal technologies to make it cost efficient. So, the last words I want to say to you, make additive manufacturing great. Thanks a lot.
Thank you.
Thank you very much. Very interesting. Any questions from the floor? Obviously, it's a very quick process to get to this point so far. How does that compare to a traditional design, prototyping, getting into manufacturing for, say, a carbon fiber frame bike in terms of the time?
What was the question?
You've obviously gone quickly to get to this point using this technology. So
how quick I get to this point?
Yeah, how much quicker is it than designing a carbon fiber frame?
Okay,
bike,
understand.
From idea to
I give you a short idea. We create one new frame for one new model in under 4 weeks.
Okay.
And then we have the next 4 weeks to make the prototype. So we are able to produce a complete new bike in under a half year.
I would like to add something to this question. Using gluing technology is unique. You might see other bicycles in this fair, you might see them outside this fair, but they are all welded. But I have a welding license myself. I'm not able to weld titanium. I'm wondering if there is someone in this exhibition that can actually weld titanium. This is a skill that is extremely rare, especially in Central Europe.
Especially in Asia.
Yes, that means we can reduce the cost of the assembly by so much just because we simply glue it.
Yeah, and also the automation. If you can always choose a welding robot, but it will cost you with periphery 1 million if you want make big sizes. With my technology, we use very small robots. They only cost 20K, and that's all.
Okay, perfect. We have a 10-minute break, so can people come up and have a look at the bike?
Yeah,
Is that
klar.
okay?
It's drivable. If you want to ride, come to the booth.
Please check your personal
Hall
liability
12,
insurance before
Hall
you do
12, sorry. E101.
There you can ride it, but I heard there's a TÜV certificate on
Ready
that one.
to
so
ride.
Don't be afraid.
it. Perfect.
And it's
Thank
an
you very much.
e-bike. You don't have to sweat.